we're looking at the very last question and look at the mix of topics in here. Mole concept, bonding structure, and Briggle formula. This is the last 15 marks. I kind of think that they're not sure like what to say. They just dump everything together here. So are you ready for the last question? So let's dive in. Okay. So with this first question here, they give you context of lead, how lead can be extracted, and they give you information in stage 1 and stage 2. They want you to write a chemical equation based on stage 1. So we're trying to identify what are the reactant first. Lead 2 sulfide is heated in air, so it reacts with oxygen. So that is our reactant, which I'm going to highlight over here. So that's where our reactant are. The things to take note here, and a lot of students tend to forget, it's the formula of oxygen. Oxygen is our diatomic molecule. That means it exists as O2. So common error that student put in here would be just simply O, looking at the periodic table and just putting O as the answer. Then we look into the product, which is going to be to produce lead to oxide, which is this. They give you the formula and sulfur dioxide. So for commons, molecules like sulfur dioxide, they will not give you the formula they expect you to know. However, this is also a challenge, so because some students write sulfur dioxide like this. Okay, this is more like sulfur tetraoxide. So if you are able to identify the reactant and the product, balancing should not be a problem. Okay, so I'm going to move on to part 2. Part 2 here, we are looking at give a reason why sulfur dioxide should not be released into the atmosphere. By now, if you have tried out like 10 plus your question, you will know that sulfur dioxide is one of the air pollutants that dissolve in rainwater to give acid rain. What is the other one? Are you familiar with it? The other one that dissolve in rainwater to give acid rains are the oxides of nitrogen. Okay, so they allow these are the other possible answer if you are able to talk about and discuss the effect of acid rain, such as it damages limestone, it kills plants, damage plants, destroy plants and fishes. That are also okay as well. All right. Then we look into a mole concept question, a 3-mark mole concept question. They have given us an equation for stage 2, and they give you the mass in tons. Very nicely, they also provide the conversion between tons to gram, but if in case they don't, then please take note. 1 ton is 10 to the power of 6 gram. Okay, they also provide MR for the substances. What they want you to calculate is the maximum mass in tons of carbon dioxide produced. So essentially, we are looking at using this to calculate this. Okay, so the first step here is to always find the number of mole. I'm going to draw out the triangle. Mr. Mole wear a mass hat. Okay, so to find mole, we want to use mass divided by MR, and the mass we will want to convert it to grams. So therefore, we multiply by 10 to the power of 6. MR is also given. That's for 223 for lead oxide. So we end up with 4 to 10 to the power of 6 mole of lead. Okay. Next, we do mole ratio based on the balance equation. You can see that the number of mole for lead oxide is 2 versus carbon dioxide is 1, so 2 is to 1 over here. And then if you have this number of mole of lead oxide, you should get half the mole for carbon dioxide. And finally, to find mass of carbon dioxide, we want to use, since we are looking at mass, we multiply the mole, which is this one, multiplied by the MR, also provided in the question. You end up with 88 tons. Okay, so this step here is in grams, but converted to tons, it'll be 88. All right, then we have a very lengthy 5 marks question. It's not that hard, but you need to know what you are dealing with. And right now there's diagram for you. So you can tell that lead sulfide here is actually our ionic substance, ionic compound. And then for our sulfur dioxide, you can see it's small molecules, isn't it? So small molecules. So this is our simple covalent bonds. Okay, all right, so they have broken down if you look at the question, they have broken it down into explaining lead sulfide and then sulfur dioxide. And what do they want you to talk about to explain? Okay, so first they want you to explain, so you must talk about the why, and then you need to discuss in terms of bonding and structure. So this is when our get student to underline. If you need to label 1, 2, 3, 4, just draw your attention towards it. It will be quite helpful as well. So you want to explain in terms of bonding and structure, why lead to sulfide is a solid and very high melting point at room temperature, why sulfur dioxide is a gas at room temperature. Okay, so bonding structure, you need to discuss why it has solid and high melting point, and then why sulfur dioxide is a gas. Okay, so first thing, structure. So lead 2 sulfide, if you can see from the diagram itself, is a giant ionic lattice structure. You need to be clear that you're dealing with ionic compound here. And to describe the ionic compound, it would be giant lattice structure. Okay, and this giant lattice structure, as you can see from here, this entire thing is our giant lattice structure. It is made up of positive and negative ions, so it's the oppositely charged ion. And how do they come together is because of strong electrostatic forces of attraction. That alone is our bonding. Okay, so we have structure, we have bonding, and then now we link it to the melting point. Why it has high melting point at room temperature? Because this strong electrostatic forces of attraction needs a lot of energy to break. Therefore, it has high melting point. Okay, hopefully you see how we underline the keywords that we need to explain and how we apply it and use those to answer this question. Then we move on to sulfur dioxide. Okay, I'm going to use blue. Okay, sulfur dioxide here is our, sorry. Okay, it's our simple covalent molecule. You can see it from the diagram as well. Okay, and what is in between this molecule here is this weak intermolecular forces of attraction between, it shouldn't be between the oppositely charged ion, this would be wrong, between the molecules. Okay, so what do we mean by weak intermolecular forces of attraction? It is, so we have this molecule, and this molecule. And what is holding them together is this dot, 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 dot. Okay, and this is what we call the weak intermolecular forces. Okay, so take note of this. And so that is our, this is our structure. This is our bonding. And because of this weak intermolecular forces, it only takes a little bit of energy to overcome. Now, take note of this word. You cannot say take a little bit of energy to break the bond. That is no marks. Okay, weak intermolecular forces, weak forces needs to be overcome. If it's ionic bonding, anything to do with like giant covalent or like ionic bonding, then we break it. Okay, so the words in, I'm going to take a moment to highlight this. These are some of the incorrect wording that students have used. For example, in this case, there is no need for you to compare them side by side. You just need to discuss each of them. So there is no need to use comparative languages. So you don't use lesser or lower, things like that. Okay? Intermolecular forces is only to be used between molecules, not atom. You can see between the molecules, not the atom. So those are common error. Okay, so take some time to appreciate the common errors and do not make them in exam as well. And finally, it's our empirical formula. I personally like empirical formula because it's, although it looks 4 marks, it's actually very easy. The steps are always the same. So we are dealing with only 2 elements. One is lead and one is oxygen. So we put them side by side. And the first step here is to use the question and make sure that we are dealing with 100% of the substances. 90.7 of lead, 9.3 of oxygen. So the first one is percentage. From the question, extracted. Then we look at the periodic table, the AR. So the AR of lead is 207, oxygen is 16. Then use your calculator to find number of mole. The third step, okay, again, Mr. Mole wear a mass hat. Okay, so this is either AR or MR over here. So if you want to find mole, all you need to do is to use mass, which is, in this case, it'll be 90.7. Oh, I should write this down just in case you're wondering where I get this weird string of number of 0.438. Okay, so I'm going to use blue. So it's 90.7 divided by 207. Mass divided by AR. That's how we get this value. You can try to punch into your calculator as well. 9.3 over 16, you should also get this value. Okay, and you will end up with a ratio. Now, if you get weird ratio like this 1.33, you do not round up or round down. If it's 1.5, you do not round up or round down. You need to multiply it. In this case, you multiply by 3, so you get to a whole number. If it's 1.5, you multiply everything in this region by 2. If it's 1.33, everybody get multiplied by 3. And that's how we end up with a ratio of, 3. Sorry, I should rewrite this. I will end up with a ratio of 3 is to 4. Okay, because everybody multiply by 3. So that's how I get my empirical formula of PB304. Okay, so I know this kind of formula does not look really conventional, but trust the step of empirical formula. It cannot be anything more or less. It's very standard, and unless you punch into the calculator wrongly, other than that, the chance of you hitting a whole number will be actually quite high. Okay, so that concludes our 2024 paper, October-November paper, and hopefully this has been helpful. All right, if there's any comment that you want to let me know, like how I can improve on this course for you, you can always drop me a DM, a direct message. Thank you.